Yes, in the last video we saw this problem based on binary search. Yeah, we see the binary search problem, and today we are going to see another problem based on binary search. So we'll use the binary search and then we'll try to solve another medium level problem. So let's see the problem. So this is like search in a rotated sorted array. So before looking at this problem, like if you have not seen binary search problem, go there and understand that, and then you can come back here. So it's saying search in a rotated sorted array. It's a medium level problem, and if you see, this is the sorted, this number is sorted, but this is rotated. Like if you see the 0 1 2, and after this is a 4 5 6 7. Yeah, so that's the next number is in this side, in the left side. So this is a rotated number, and we need to search the item in this list, and we need the performance is a order of log n. So we have to use the binary search technique. So the way we search in a binary search, exactly we'll use the same technique, but there are a few additional things we have to look at this. So what are the two additional things is, first we find the midpoint. So in a binary search we know, like, we find the midpoint. So here also we find the midpoint. Okay, so once we find the midpoint somewhere, let's say this is the midpoint, or this is the midpoint, then we'll check, like, this beginning number is less than this midpoint number. If it is less, that means this is sorted, this portion is sorted. If it is less, then it's a sorted. So let's say here beginning number is 4, so 4 is less than 0, no. So in that case we'll see our target number in next section, like this 1 2 section. So let's assume, if the beginning number is less than this mid number. So in that case we also check, our target is between this. If the target is between this, then we'll set the midpoint to 7 here in this section. So again we'll check that, okay, this number is less than mid. If it is not, then we'll go to the next right portion, and here also we'll check if the number, our target, is between this this section, right section, then we'll move our beginning to this place. Okay, so that's the two things extra we have to implement in our logic. Let's see the code and we'll get a better understanding. Okay, so first thing we need begin, or let's say beginning is 0, and end is length of nums minus 1. Okay, and in a binary search we know we use this condition for beginning less than equal to end. And in a binary search we do is, this line is exactly same as a normal binary search, mid equal to, so beginning plus end minus beginning divided by 2. So till here exactly same. And then we also check if nums mid is equal to target, then return mid. So till here it's exactly same in a binary search. Next portion, so next portion I was saying, if this number is less than mid, so that's condition we have to use. If nums, or we can, yeah, nums beginning less than nums mid. So that means if the nums beginning, if this number less than mid, then search in this technique, search in this portion, left portion. So that's why if this condition, else search in another that's the right person. So that's a else is for right person, this is for the left person. Okay, so if the first condition satisfy, that means we have to check our target is between this and mid. So I can, so the logic can be less than equal to here. I can say if target is greater than this nums beginning, so greater than equal to beginning, and target less than equal to nums mid. So that means if the target is greater than 4 and less than this midpoint, so in this section, so if it is in this section, then end will be mid minus 1. So end mid minus 1, because we know if you make the end mid minus 1, that means our target will be in this portion. Else begin equal to mid plus 1. Okay, then the similar way, if the first condition was not true, then we are supposed to search in the right section. So in the right section, we'll check if target greater than equal to nums mid. So in this section, target greater than equal to this mids, and target less than is equal to end nums end. If this is the if this condition is true, that means our target is in right section. Then we move beginning here. So that means we can set beginning equal to mid plus 1, else end equal to mid minus 1. So that's the logic. Let's try to run and see for any error. Target spelling wrong. Target. Let's try once again. Compile time error. Let's see here. Okay, so return is at the end. If you do not find anything, then return minus 1. Let's try one more time. Okay, accepted. Let's try to submit this. Accepted. Yeah, it worked. 60 bit 62.9. Okay, so let's see exactly the same algorithm in Java. So for the Java I have already done. So let's see the code. The code is the same in the begin and end, and while logic here the same like in the binary search, begin less than end. We're calculating midpoint here, and then checking if the mid equal to target, then return mid. Otherwise we need this logic. So nums begin less than nums mid. So from the mid, this mid, and this beginning less than this mid, then our target will be in the left section. Otherwise the target will be in the right section. And if the target is in left section, then we're checking target greater than this and less than equal to mid, target greater than equal to this begin, and target less than equal to mid. In that case, end equal to mid minus 1, else mid plus 1. Otherwise we check target greater than this mid. So target greater than nums mid and target less than nums end. So in that case, we can move begin. So that's why the begin is equal to mid plus 1, else end equal to mid minus 1. Yeah, so that's the same logic here also. Yeah, that's all for today. Thank you.